This video was produced by Vivonix. The following images may be disturbing to some viewers. Discretion is advised. The Vivonix Project patient, or physical anatomical trainer instrumented for education and non-subjective testing, has the objective of simulating a realistic liver for surgical training and feedback. This video covers the patient system overview, the test procedure followed by a test conducted within a laboratory setting, and the conclusions of the experiment. The patient system consists of three main subsystems. The first system is the artificial liver. The liver is constructed from a polyurethane foam and a urethane rubber encapsulation. The liver also has a 9x9 insulated wire mesh which feeds into the computer hardware, allowing cuts made on the liver to be spatially located by the program. Two inlets diffuse the blood analog into the liver, and one outlet returns the simulated blood to a reservoir. For each inlet and outlet, an omega 005 pressure gauge and a flow meter are used to monitor the fluid dynamics. This subsystem is mounted on a plastic sheet with the electrical and flow systems hidden and protected underneath and the liver easily accessible above. The second subsystem is the pumping mechanism to simulate realistic blood flow. A reservoir of a blood analog feeds the peristaltic pump, which forces the blood through a tube and then branches to the two inlets of the liver. The outflow from the liver is then deposited back into the reservoir. The third subsystem consists of the computer hardware and software. The hardware is composed of a National Instruments DAC board, which has channels connected to the three pressure sensors, and which outputs 5 volts to the wire mesh sensing system. The mesh sensor system is composed of 6 fidget differential voltage sensor boards, 24 resistors both in parallel and in series, and cabling that meets the liver wire mesh at a junction location on the plastic sheet. Fidget flow sensor boards are also present. The software is a LabVIEW program. The inputs on the screen are start and stop buttons. The outputs include error dialogues, sensor circuit statuses, 3 junction graphs each split in 2 with waveforms depicting the pressure and flow rate, an image of the liver with a red mesh overlaid to indicate the spatial locations of the cuts, and instantaneous sensor indicators. This section of the screen displays where the user has made an incision into the organ. The grid shown corresponds to the wire grid that is embedded into the liver. When the liver is cut, the corresponding sections of the grid on the screen light up green. Here are the 6 graphs showing pressure and flow. Pressure and flow are recorded and displayed for each inlet and outlet. After priming the flow system, the blood simulant is passed through the liver at a rate of 1 liter per minute. With the LabVIEW program started, the surgeon trainee slices into the liver at points indicated by the trainer. For each cut, the LabVIEW software will recognize where the cut has been made by determining which mesh wires have been severed. If the cuts are sufficient, then the blood will perfuse through the opening. The following set of images and videos depict the surgical training demonstration. The patient training system is a suitable replacement for practicing surgical techniques without a cadaver. The system is also cost-effective compared to the cost of procurement of cadavers and alternative artificial training systems. Future implementation will include a higher resolution mesh for finer spatial recognition of scalpel cut locations. In addition, more organs will be implemented to increase simulation of the flow system and inter-organ dynamics during surgery.